Good afternoon to everyone in the conference room and those who are attending online. I'm very happy to share my contribution to these important conferences in the field of digital technology and optimization in architectural and structural design. My name is Ilda Rusi. I am a lecturer at Polish University, which is a private university operating in Albania at its 90th year of life, with the main mission to provide leadership to the study programs in the territory sciences from urban planning, architecture, civil engineering to management development. So my presentation today will be focused on structural facade using perforated structural wall panel for multi-story buildings. Due to rapid development and population growth in major cities around the world, the number of multi-story buildings has significantly increased. So these buildings offer a practical and cost-effective solution for many urban development needs. There is a growing interest, on the other hand, in exploring structural systems that facilitate the construction of multi-story buildings. As noted in the literature by several authors, one of the key issues in designing multi-story buildings is balancing architectural considerations such as space, function, and light, while on the other hand ensuring also structural rigidity. So based on engineering reasoning, providing adequate structural rigidity frequently requires substantial cross-sectional dimensions for structural works. So this presentation is based on a 4-year research on innovative structural system techniques in multi-story buildings, research supervised by the Department of Scientific Research at Polish University and the Department of Architecture at University of Facade. In multi-story buildings, the position of the structural walls are usually dictated by functional requirements. So, in this regard, as an optimal solution in order to fulfill the above requirements, it is being clearly stated as suggesting the using of perforated structural wall panel as an aesthetic element with a significant architectural performance to be an integral part of the facade of multi-story buildings. So this study offers a novel method for exploiting perforated structural wall panels to achieve architectural performance in multi-story buildings. It is proposed a triangle 3B panel layout, which is classified as frame-braced wall, and is a noteworthy example in this regard. So the multi-story building experiment features a perforated structural wall element that improves structural behavior, while at the same time can be seen as a structural and architectural element. So the element itself, in addition to the aspect of structural stability, offers the opportunity to be used in the creation of various architectural designs for multi-story buildings. So in the current design challenges, there are limited integration of perforated concrete structural wall elements in conceptual design, so there is a need for multidisciplinary methods to balance aesthetics, functionality, and structural rationality. While architects emphasize form and expression, the engineers emphasize safety and cost efficiency that results somehow in polarization. So, on the other hand, clearly digital and computational advances generative design fosters innovative and fluid structural typologies. In this sense, for future directions, it is foreseen the adaptive architecture, which is proposed as perforated panels that are energy-efficient building envelopes that ensure sustainable materials that also have resource-efficient, recyclable perforated facades that integrates aesthetic, structural, and also environmental performance towards a holistic building design. So it is often of great interest to discuss the different arrangements of pattern openings. So several cases of wall openings are represented here to meet the requirements for accommodation doors and windows in buildings, along with relevant recommendations. For instance, when openings are positioned very close to each other in the horizontal and vertical directions, it can be challenged to make the connections sufficiently ductile and to prevent early damage during earthquakes. So therefore, it is preferable to avoid this kind of arrangements. Using these techniques in the Grasshopper and Caramba plugins, different forms of openings can be treated aesthetically while ensuring the stability of perforated panels. So the triangle 3D model was selected and analyzed in detail through an analytical process. First, for the stability of the perforated panel, and then for its adaptation to similar cases. The generation of one or more perforated panels, which are then structurally controlled, is valid up to the stage of model analysis. So this analysis is based on the theory of top displacements of the perforated panel, ensuring that the displacement limits comply with the design code of each country. So to generalize the analysis cases of this process, several structural checks were conducted. Since the main working scheme of this structural element involves itself compression and tension elements, each of these elements was checked individually. In the case of perforated panels, the wall elements, brace frame walls that work in compression and are first identified, and then the control is performed in accordance with the relevant formulas defined by the design code. So let's see which are the three main headings under the discussion on optimal dimension of perforated structural walls. We have the importance of dimension selection, the design context and case configuration, which propose design alternatives and decision making and the final solution under configuring the efficiency, economy, and the integrity, both aesthetic and structural. And for the discussion on multi-story buildings configuration, they are described the tubular systems concept that maximizes usable floor space, that reduces internal support, simplifies core design, and the relevance to perforated structural wall design that aligns with the modern objectives, optimize material use, cost efficiency, and architectural expression. And on discussion of structural model of selected pattern, there are given the sum of methodological workflow, performance assessment, focus on stability, stiffness, and focuses also on several case studies with the main part, which is the outcome of triangle 3D panel that do give a synthesis of architecture and engineering. The design that is visually expressive, it is structurally efficient, and also is economically rational. And we have two other discussions regarding the strategy of structural wall positioning, dealing with optimal core perimeter collaboration, and foundation detailing the results in improved seismic performance, reduced material costs, or architecturally integrated structural design. And under the topic of discussion on stable perforated panel configuration, we do have here the performance-based design that with the main key objective that meet the maximum displacement targets under lateral loads, emphasizes on integrated structural logic with architectural design, and supports co-design process balancing efficiency, aesthetics, and structural performance. So finally, to sum up some conclusion, this research do presents a new technique for achieving architectural performance in multi-story buildings using perforated structural walls that gives a significant example in the case of triangle 3D panel configuration, which is structurally defined as frame brace wall. So this perforated structural wall element, located at the periphery or perimeter of multi-story buildings, enhances structural behavior while also contributing to a cost-effective design process. Thank you for your attention.